These are the information that we have, the number of bedrooms and the price of the house in San Jose area. We collected this information. We want to know what is the regression line. In your calculator, the regression line is represented by ax plus b, and a is the slope. So first, make sure to click on second, and then catalog, which is 0, and then find diagnostic. It needs to be on. So double click on that, and it is on. Now you need to go to stat, then edit, and enter these information. Enter X in L1 and Y in L2. So let us begin. Stat, edit, L1, I have 4, another 4, another 4, I have 2, I have 3. Guys, make sure these numbers match the Y value. So you need to have the correct amount of 3s here. 1, 3, 2, 3, 3, and 5. Then you have a 3 at the end. Now let us move on to L2 and enter the prices. 2, 8, 5, 0, 1, 2, 3. Then you have 2, 0, 95, 0, 0, 0. The next number, 2, 8, 95, 0, 0, 0. Then you have 8, 39, 0, 0, 0. Then you have 299, 0, 0, 0. 1,898,000. Then 299, 900, 131, 9999, and the last number is 19988. Very good. So we entered this information into L1 and L2. Now, what are we going to do? We're going to go to stat, go to calc, and then find linear regression. So stat, calc, and find linear regression ax plus b. Very good. My L1 has x values in it. My L2 has y values in it. So you go to just calculation. Well, it calculated a regression line for you, and R, or the correlation coefficient, is not a good number. It means that we don't have a good association between these x and y values. So here, your A is 642597 approximately. B is about -802735 approximately, and R is 0.53 approximately. So this guy is important. Why? Because it helps us to analyze this data. It says, hey, the correlation coefficient is not strong. It shows a weak association between the number of bedroom and the price of the house. Why is that? There might be a non-linear association here. You might have lurking variables. Lurking variables. For example, what are those lurking variables? Renovation. Renovation of the house. Being close to a mall. To a shopping center. Is it in a safe area? How about schools around the area? So these are all lurking variables that affect the relation between the number of bedroom and the price of the house. You might have a nonlinear relation. What's the meaning of that? It means that, for example, you might end up having an exponential relation between them. So exponential relation. When we're talking about exponential relation, we're talking about a function f of x equals to, well, you have some initial values like a times b to some exponent to some powers. When you have functions like this, the behavior of the function is going to be either increasing this way. For example, you might have f of x or y equals to 2000 times, I don't know, 3 to power x. The initial value is 2000 times the base raised to power x. Some other time, it is decreasing. You might see this trend between the data. It might be like this. So in this scenario, for example, you have y equals to the initial value stays the same, for example, but here you have a third to power x. As long as this number, the base or b, is more than 1, you have increasing trend, but as long as b is bounded between 0 and 1, a third, a half, 1/10, 2/3, and so on, you get a decreasing trend in your data.